going live. And let me share my screen meanwhile. Okay, and there's our stream. And let me mute that. Very good. And I'll minimize this. Oh, did I leave the other stream going? Wait a minute. Uh-oh, did I leave the other stream going? Okay, I think let me close that. I'll make sure I don't have the other stream going as well. Okay. All right, let's minimize that. Very good. Okay, that's prior. Okay, let's see. Any questions on the chat? Let's see. Does this course start at 3:35 or 3:25? Normally starts at 3:25. I'm sorry I was late today, so we're starting a little bit late, but that's fine. Let's get started. Let's see. Yeah, so let's go over a couple of administrative issues here. We, as you know, we have the syllabus, right? If you click here, you have the syllabus, and in there you'll have the agenda. And I always like to come back here just to put us in context where we are. The first week we talked about how to install a database. We installed the SQL Server and the client workbench. Last week we talked about how to design the database in terms of class diagrams. Let's see, a question in the chat. Can you clarify what classes need to be in the homework? Because there's different examples and now you do it parts, and I want to make sure I did it right. Yeah, so the first assignment, you need, I believe, 5 classes, right? The users, the blogs, the posts, the replies, and the review or something like that. Yeah, there's 5. There's in total you should have 5 classes in the assignment. Rating, yes, thank you. Some of them we showed you how to do them in the assignment, and some of them we asked you to then do it yourself. But in the end, it's one class diagram that's going to have 5 classes, right? User, blogs, rating, posts, and replies. Okay. All right, and so yeah, last week we spent some time talking about how to design the database in terms of UML class diagrams. So this week we're going to focus on how to implement it using relational model, right? So we spent some time in the conceptual model, right? Using drawing boxes and arrows and lines and stars and numbers and whatnot, right? And so this week we're going to go and make that concrete. That something that was so abstract, we're going to make it more concrete, and we're going to implement it using relational databases. That's why we call it the relational model, which is basically transforming it from class diagrams in terms of tables. Okay, so yeah, and so let's spend some time there. There will be a quiz later this week on Friday. Remember, the quiz is no longer you need to be here during class time, right? You can take the quiz anytime from Friday morning, early morning, all the way to Saturday at midnight, right? So you'll have a full 48 hours to take the quiz, starting Saturday morning all the way to Saturday at midnight, okay? It will, and then it'll be available throughout. This is during Eastern time, right? So morning and midnight at Eastern time. Also, there's an assignment due later tonight, and we're going to be introducing today the third assignment, DB3, which we're going to go over today. I'll get you started. I'll do some of the work here just to demonstrate how you would go about it, and then we'll ask you to do some on your own. let's see, something on the chat. When does the time start for the quizzes? 8 a.m. Well, no, it starts at midnight Thursday, which is 12 a.m. I guess. On Friday at 000 Friday, and goes all the way up to Saturday at midnight. All right, and this assignment will be due next Tuesday. Okay. All right, thanks.
Professor, I have a quick question regarding this homework assignment. So I know it says to turn in a PDF, yeah. But the website I used to make the class diagram, you have to pay for it to convert it to a PDF. Oh. Is it okay if I just do a screenshot and then convert that to a PDF?
That's fine. Even just if it's an image, that's fine.
Cool. Thank you so much.
Yeah. So apparently the quiz says that it's due Friday at midnight. I'll definitely make sure that it's changed to Saturday at midnight. All right, so let's take a look at the a couple more administrative things. So make sure that you stick to Piazza if you have questions. You can come to the lectures either at 1:35 or 3:25. All these videos that we're streaming, they should be available at my YouTube channel, available right away after the session ends. And I will be adding them to a playlist, which you access here. Or, of course, these are all being recorded in Zoom that you should be able to have access as well. Good tool, yeah, ping to ping. Okay, awesome, thank you. All right, also you have here links to the office hours. Please make use of the office hours. Go to the TAs or myself later tonight. We also have obviously the all these available from the prior weeks, and we're going to be focusing on the third week here. Okay, so let's take a look at the third assignment. So the third assignment is going to focus on the on implementing a class diagram in terms of a relational model. Right? We're not going to convert all these classes. Obviously, some of these classes are basically this is kind of like the solution to the second assignment. But there's a mistake here that I need to fix still over here. See that this is supposed to be a 1, and that's supposed to be a star. Right, so this is supposed to be a one-to-many between user and blog, and then a one-to-many between a blog and a post. So this is you're supposed to be a 1, and this is supposed to be a star. I'll fix it later. Chat. Also, if anyone is using a Mac, if you have a screenshot and then click on the image, then you should be option to convert to PDF. Okay, excellent. All right, so today we're going to focus on implementing some of these classes. We're going to convert them into tables. Not all of them. We're not going to do follow. We're not going to do topic, right? We're going to do that a little later next week. We're going to focus on user, reply, blog, rating, and post, which is basically the classes that you implemented last week. Okay? We're going to first create the users tables. We're going to give you that, right? We'll give you that, so you don't have to do that, right? But even if we give it to you, even if we give you the code, we're going to ask you to store all your SQL in separate files, right? So for instance, this code of creating the tables, we're asking you to please put it in a file called createuserstable.sql, right? And save it and then submit it. Even though we are giving you the solution, right? So I'm going to demonstrate how you would go about doing this, right? So let's say here we have the schema here from 04 for this section. I'm going to double click it, right, to make it the default schema. I'm going to close this a little bit, so don't save, and close this, don't save, close. Okay, close it. All right. Okay, so we have a couple of tables here from last week, and let me show you how you would go about this. Copying this, you copy this, and then you paste it here. You paste it, and now you should have a schema called DB design, right? Which you should have created in the first assignment, right? So this code is based on the fact that you should already have that. right? So if you called it something else, this code is not going to work. For instance, I have it, and obviously this code is going to work, but I want to work under my schema, DB schema 04, right? So I'm going to change this to B underscore 04. So it's implementing it. These users are implemented. It's created inside of my schema 04. Now there are two commands here, right? There's a command called drop table, okay, which, like the name suggests, is going to blow away the users table in that schema, right? But only if it exists, okay? After that, I'm going to create the table brand new, okay? It's a good idea to always have a drop table before a create table, so that if you already have the table already there, this create table is going to throw an exception, right? It's going to give an error, right? So if you're still playing around with the schema and you want to try out different things, right? It's a good idea to drop the table and then just recreate it. Obviously, if you have a lot of data in there, maybe it's not a good idea to drop the table, because you're going to blow away data that you already have in there. Okay, so we got to be careful. So to execute all the commands, you select the entire text, right? And then you click on this lightning bolt, right? If I click on that, it executes both. Actually, something didn't like the create table. What's wrong with my create table? ID not null, yada yada yada. Erica, unknown database DB design 04. Oh, DB. Oh, did I call it DB schema? Oh, sorry. It's DB schema 04. There we go. Let's do that. Okay, let's try it again. Let's run this. Let's select the whole thing and run it. Okay, so it looks like, okay, now it worked. Okay, so now if I refresh, notice the refresh button, it shows now that I have two tables, right? The courses table from last week and the users, which has the columns that are listed here. Let's look at the columns that I created. One is going to be our unique identifier, our primary key, right? That I'm saying that it's an integer, and it's not null, meaning that it's required. You better have a value when you insert. And also, I'm going to delegate that value selection to the database. The database is going to select what value it wants, right? So it'll start at 1, then 2, then 3, and 4, and whatnot, right? Some databases can start maybe at 10, 20, 30, and 40. That's up to the database. So that ID, I also later on say that this is a primary key, okay? Meaning that value needs to be unique, and it needs to be not null, right? And later on, it's going to be able to participate in relationships with other tables, right? Which we're going to build a little later. Okay, excellent. So we created users. It has a first name, last name, username, password, blah, 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 right? Some of them are strings. Some of them are dates. Some of them are integers, okay? The ones that say null means that it's not required. So it is okay not to have a value for it. Some of them say that this 45 says that this string can only be as big as 45 characters long. Now this one says that this created field is a date time, so it's like a timestamp, that it can be null, right? But I am providing a default value of the current timestamp, right? So it's going to take a look at my current time in my local machine, right, and use that to, when you insert a new record, right, it'll automatically grab the current timestamp as a default value for that new record. The same thing for the updated. I want to keep track. Basically, what I'm doing is I'm keeping track of when records are being created, or when is the last time this record was updated. So by default, both have a current timestamp, right? By default, when the record is created. If the record is updated, then here I have an additional constraint. In this up field, might as well just have it in the same line, right? Like that. But for easier reading, right, I'm putting it in a separate line down below. I'm saying that this field, if you update any part of the record, right? So on updates, change the value of the updated field to be, again, the current timestamp. So I'm always keeping track of when was this record the last time that it was touched. Make sense? All right, excellent. One thing that I might want to do here, that instead of usernames being, oh, no, notice that I'm saying that the username here has not null, meaning that it is required. You cannot make a record without the username and without the password, right? Whereas first name and last name, we can let you, type your first name and last name later on after the record has been created, okay? And you can give me the profile picture a little later. All right, so we created this table. There's another way that we could have created it. Let me show you another way that we could have created it, right? So I'm going to select here in tables, and I can say, right click, create table, or I can also come here in the plus here. See that? And create the table. So let's use this. So this graphical tool over here will allow us to create tables as well, right? So you can type in the name of the table. So I'm going to call users, and I'm just going to I'll put a G next to it, just so that we know that we use the graphical tool to build this table. And so we'll have a primary key here, ID. So by default, the graphical tool will assume that the first field is your primary key. So by default, it will choose int, and we'll also choose primary key and not null by default. I'm going to just add AI for auto increment. There we go. See that? See that it automatically chose PK and not null there. I only added AI. Well, let's add a couple more things here. So we have maybe the first name. Notice the naming convention I'm following. First name is a compound word. It's two words in one. First and then name. In other programming languages, typically you would use this naming convention where you capitalize the first letter of each word, right? When you separate them like that, right? Because it makes it easier to read. Now, that's fine in other programming languages because they're case sensitive. SQL is not case sensitive, so we're going to use instead the underscore to separate the words, okay? And so I'm not going to say that it's not null because this is not required. Let's add another one. Let's do last name. Let's use username. Now, username, I do want it to be required, so I'm going to select not null. And password as well, I'm going to select not null. And then it's a profile picture as well. Profile picture. It's varchar as well. Probably a little longer than 45. Maybe I want to say 256. Okay, characters. Maybe it's a long URL to an image or something. And that's not required. And let's do also created. Created. This is going to be date time. There it is. And this is updated. All right. This is also date time. Oops, date time. Now notice that here in the last column we have that we can specify default values, meaning when folks start to insert records, we can specify what we want those values to be by default. Okay, so we're going to say that we want for this to be current timestamp. Okay, that's going to be the default value. And this updated is also going to be current timestamp. So current timestamp. Okay, but on updates, I also want it to be current timestamp. Okay. All right, excellent. What else? Okay, that's about it. Let's try it out. If we click on apply, let's see. Let's click on apply. And what it does is that it writes the SQL for you. Okay, this is the same SQL, hopefully. Right, it'll be the same SQL that we gave you. Right, we have the ID, not null increment, the first name and last name varchar, username and password not null. Right, the profile picture varchar null, created date time, current timestamp, default timestamp, same thing, default timestamp, on update, blah, 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 blah. Okay, so this is a good chance for you to copy this. You can copy it, and then you can apply. And it says that it was okay. I'm going to close that. And let's see if it worked. I can refresh. Oh, there it is. There it is, right, with the correct fields. Okay, excellent. Now the code that we copied and pasted from the assignment. It's right here, and you can just save this. You can say save, and you can save it into a file like that, create users tables and save it for later. Now, what if you forgot to copy it, right? And, you know, maybe you wrote it and you copied it. You can always retrieve the code. You know, you can open a brand new SQL here, brand new SQL window, right? And you can right click on the table and you can say, send to the SQL editor. This is the SQL editor over here, right? You can say send to the SQL. You can right click, send to the SQL editor, the create statement that was used to create this table, right? And there it is. You can look at the original code that was used, right? You can also just send it to the clipboard instead. Copy the clipboard, the create statement, it copies it. Now you can paste it, right? You can say paste. There it is, right? So you can retrieve it in either way. Okay. All right. Excellent. So we created the users table. So and you're gonna save it into this SQL. You're just practicing, okay, here, right? You're just getting your hands a little bit dirty, right? And as you practice, you'll become more proficient. Let's see something on the chat. What is the last line? Okay. Oh yeah. So there's different engines. So MySQL has different engines on how the data is being stored in the file system and how it's optimizing this content. And the default engine for querying the data and retrieving data from the file system is INODB. There's several, a whole bunch of, you can choose which one. Also how the character set is being, you know, whether it's using UTF-8, UTF-16, you know, Latin, you know, there's many different ways of representing character sets. So yeah, so that's the default. You don't need to include that in your code to create it, but here it's adding it so that you know what engine was used for handling your query. All right, so once you practice this, right, we're asking you to do it on your own. Well, actually, not yet. Here I have a little blurb on why we used you know, this naming convention as opposed to capitalizing, and so definitely read up on it. All right, so now we're going to create another, we're going to create another table. Probably the users table you had created already in your first assignment, right? So you can recreate it here. All right, so let's create now the blogs table. This one over here, implementing the one-to-many between the user and a blog. So one user can be the owner of multiple blogs. So the way we're going to implement that is that we're going to do the same thing. We're going to drop the table. We're going to create the table, the primary key, yada, 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 right? The fields. But we're going to add an additional field. Actually, this I think I prefer this to be user_ID. And that means that this has to be, I have to fix that. I need to fix that. And DB users ID. Yeah, like that. And we'll verify that this works, right? So we're going to give you this table as well. Let's copy this. We can go back to Workbench and create a new SQL window here. That's a new SQL editor. I'm going to paste this in there. Let's see if there's any errors. It looks like there's no errors. The only thing that I'm going to change here is that I'm not working under DB design. I'm working under DB underscore schema 4. So let's change that. So this is DB schema underscore 04. Let's copy that and paste it here, here, and over here. Okay. So let's review this real quick together. This is saying that, you know, if the table already exists, just drop it, remove it, and then create a brand new. Create a primary key. This ID is required, not null. It will auto increment on its own, and it's the primary key. Okay, meaning other tables can refer to records using this field ID. Then I have here a couple fields that are, you know, natural fields of all blogs, you know, the name of the blog, the topic, and so on and so forth. But then here I have a field called user ID, and which I am going to use as a foreign key. I'm going to use this field to refer. I'm going to use that field to refer to the ID field in the users, so that it'll know, each blog will know who the user is, right? Who its user is, right? So that's what I'm going to copy there, right? Then I have created and updated. This is the same thing that we looked at earlier in the users table, so I'm not going to cover that again. So there it is. ID is a primary key. This index is not necessary, but it's the tool had created it for me, so I left it. And here I'm creating a constraint. I'm saying I'm specifying that the field user ID that you have here, right, is a foreign key, and that's going to reference this table, right, by the primary key ID, meaning this user, this ID here, right, meaning that these values are going to be referencing those over there. And that field ID, if ever the record that I am referencing is removed, then I am going to be removed as well, right? We're saying that cascade those actions in that other record, propagate those changes to myself as well, right? If my parent record goes away, I want to go away as well. Or also if, let's see, Audio raised their hand, let's see. That will be a composition. Yes, exactly. That would be a composition. Perfect. Very good. Very good. Yep. This is how you implement composition. Was there a question?
Yeah, Professor, I have a question. Aren't so you index user underscore ID, which is a foreign key. I was gonna ask, aren't foreign keys indexed automatically, so you don't have to do that?
No, here we are specifically saying that we are indexing, and we'll talk about if it's a good idea to index or not. Sometimes it's not a good idea to index, depending on how the grouping of these keys, especially because this key here is not a unique key. It's always a good idea to index a primary key, but it's not always a good idea to index non-unique keys. And we'll see about performance issues that you might run into if you do index non-unique keys.
Okay, thank you.
So, and this update, you're welcome. And then this update says that if the field in that other table changes for some reason, right? The primary key was 1, 2, 3, and it changed to 2, 3, 4. Well, we want to change 2, right? Because I am referencing you, right? I don't want to be left orphaned referencing something that doesn't exist anymore, right? If you move around, I want to know where you moved so I can still point at you, right? So I am cascading, I am propagating those changes to my field as well. Chat, what? Yeah, cascade. So cascade means to propagate, right? If something changes over there, I want to change too. Right? So propagate those changes to me, cascade those changes to me, right? You visualize it as being, you have the thing that you're pointing is above me, and whatever it does, right? It cascades, it drops, it falls on me as well. Okay, like a waterfall, right? It's cascading, it's falling onto the next level, Okay, so let's run this. So I'm gonna select all, right? So by default, when you run this lightning bolt, it only runs where you have your whatever you have selected. But since we want to run both of them, we're going to select everything and run. And let's see. Yep, it was able to create the table. Let's refresh here and notice that now we have the blocks table. Perfect, excellent, with all those fields in there. Very good. and you're going to save this. Right? You're going to save this to create block SQL. And so we're going to save this to there we go. Create blocks table, save that. Okay, perfect. And you're gonna submit that as your deliverable. Okay, so here down below I have a blurb copying this. Could have done this graphically, and so I show you some screenshots of what we did just 2 minutes ago when we created the user table, right? When we created the user G here, this table, we did it graphically. I just copied and pasted some screenshots just to remind you that you can do that. Oh yeah, so let me show you blogs. We could have done blogs graphically. In particular, I want to show you how you would have done these foreign keys, right? Because we know how to do everything else, but we don't know how to do these foreign keys graphically. Let me show you. So let's create here graphically blogs, right? So I'm going to create table, and this is going to be blogs graphically, right? And we're going to have ID for the primary key, which is going to be auto increments, and it's going to have the name of the blog. It's going to have the topic of the blog, right? It's going to have the user ID, which is going to be my foreign key, referencing the user who I belong to, and I have the created and I have the updated. So I'm not going to do created and updated because we did that in the previous one. I demonstrated that previously. I'm just going to change it to date time. Okay. All right. So now I'm going to go to foreign keys. Right now, I don't have any foreign keys. Okay. Let's see. There's questions on the chat. Am I the only one lagging? No, the audio is breaking up occasionally. Not sure what to say. You mean the when I move, everything being fine for me on Zoom. So on Zoom is fine. Maybe
it's not super bad. It's just like every once in a while.
Yeah,
like
yeah.
A line of words.
Are you following me on Zoom or on YouTube?
I'm on Zoom.
Zoom, okay.
Yeah.
Huh.
Yeah. When you were introducing that table, you said like, I have this table here. You broke up and we couldn't hear what you said.
All right. Okay. So yeah. So please let me know. So I'm obviously happy to repeat. Is everybody following? Did I lose anybody, or is everybody still okay with me?
Oh, good.
I'm going to assume yes. Okay. All right. So yeah. So I've created this, right? And if this were it, right, then that's it. I can just say apply. But I want to do a couple more things here. I have this user ID that I want this user ID to be a foreign key. I already set this ID to be a primary key, and that's all I have to do for this to be a primary key. But for user ID is a little more involved, right? We're going to go here in the foreign keys, and I'm going to create a brand new foreign key, and I'm going to give it a unique identifier. Now, this foreign key needs to have, all foreign keys need to have a unique identifier. You can have just some random name, doesn't matter. I like to give it some logical name that I can guarantee for this to be unique. I'm going to say that this foreign key I'm going to create is going to relate two tables. I'm going to relate blogs to users, right? It's going to relate blogs to users. And I'm going to say, these are the fields, right, in my local table. And this is the table, this is the field that I'm going to be working with. But first, before I can select that, I first have to say, what table am I going to be referencing? Well, blogs are going to be referencing the users table, right? So I'm going to have here, I'm going to reference, not the courses. I'm not going to reference myself. I'm going to reference the users table. Once I do that, I can then go and say, okay, which field is going to reference that users table, right? And so in our case, it's going to be this user ID. This is the field that's going to reference the users table. And then you have to select, well, what is it going to reference? In that table, the users table, what are we referencing? And notice that it lists all the fields in that foreign table, the users table. We're going to reference the primary key. There it is. See that? Do not have compatible types. Oops. What do you mean? When I created users, what did I create? Uh-oh. It's int. Oh, maybe in my user table, I did it maybe a varchar. Maybe let's go back to the columns. User ID. Oh, yes, I left it as a varchar. No, that's not what I want. I want this to be an integer as well, right? Because it's going to be referencing a primary key, which is also integer. All right, let's go back to the foreign key. I meant to do that just to as a learning opportunity. Okay, so the user ID, it's going to reference now the ID. Hopefully now it's going to be okay. Yep, okay, now it's okay. It is referencing that primary key. And notice that by default, right, if the primary key I am referencing, this ID, if it changes, I don't care, right? If it's removed, I don't care. This is the no action says that says that you don't care if they change. Or you can change it to restrict, meaning no, don't let it do that, right? Don't let the other record, if you remove it, I'm going to be left orphaned, right? I'm going to be referencing a record that doesn't exist anymore. Okay, or I can say set to null, meaning if it's removed, then I don't want to be left referencing something that doesn't exist anymore. At least make me null, so I'm not pointing to anything, right? Or you can say no action. That's the default here. Or you can say cascade. Cascade means that if the other record is removed, I want that action to propagate, to cascade on me as well. Or if it's updated, I want to update too. Okay, so if I do the apply, there is the code from that I showed you earlier, right? We have the ID, the varchar, the topic, the user ID is integer, right? And there's our constraint, and the we're referencing that we're saying that this user ID is referencing this other table, and that primary key and the cascade over here. Yes, excellent. And I'm going to say apply. And there's our two blogs. Okay, very good. All right, so in both cases, right, you can implement it either way, right? You can do it graphically, or you can do it manually, or type it away. Okay, we showed you both ways. Okay, having practiced that, we just implemented a one-to-many, right? We implemented users to blog, right? One blog, one user has many blogs. We want you to implement this one-to-many, blog to post. One blog can have many posts. Notice that this is written correctly, one-to-many, and over here it's written wrong, which I'll fix later. Blog to post, it says many-to-one. It's listed as if it were a mapping table. It's not a mapping table. Right, this is one-to-many, and then a one-to-many again. Okay, it's here. It's rendering as if it were a mapping table. It's not a mapping table. Okay, so we want you to implement this, right? Basically, you're going to create the post table. You're going to have the title, the post, the created, the updated, blah 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 blah. Right? You know how to create this. The default values, the current timestamp, and you're going to have a foreign key, right? This post table is going to have a foreign key called, say, blog, underscore ID, that references the primary key on the blog. Yes, right? So we're going to let you do that on your own. I'm going to create the post table because I need it for later, right? I'm going to create the post table, but I'm not going to do any of this for you, right? So let me create the post table here. So tables, let's do create table. And it has the ID of the post. Oops. And by default, again, it's primary key and it's auto increments. And that's all I'm going to do. I'm going to do, you can do the rest, right? And it's going to be called posts. And apply. All right. And there it is. There's our posts. Remember, the only reason we put an underscore G here, right, is just to remind me that I created it graphically, right? You don't have to follow that naming convention, right? It's only because I wanted to show you two different ways of doing it. So there's posts, very good. And so you're going to implement posts with a foreign key to the blog, okay? Then you're going to save that in this file, right? Then you're going to create a many-to-many. So we're going to practice on how to do a many-to-many, right? So first we're going to do it, and then you're going to do it on your own, all right? So I'm going to create the reply table here, which is going to be a many-to-many, right? Basically, it's a reified many-to-many, right, between user and post, but we're capturing the reply, right? And so first we'll do just a simple many-to-many, and then we'll show you how to do this little loop over here, right? Like a self-reference. But you don't have to do that, right? I mean, we're here for the reply table, but later on when you do your many-to-many, you don't have to do a loop for that, right? It's just showing you here how to do it for the reply table. Okay, so let's implement the replies table. I'm just going to copy this. I'm going to bring it over. I'm going to open up a new SQL editor. I'm going to paste that, and let's read through this, right? Okay, so here's the schema. So this schema should be DB design, DB, what? DB schema underscore 04. There it is. Let's see. So I'm creating the replies table, has a primary key. Here's a natural field that keeps track of replies. I have two foreign keys, one referencing the user and one referencing the post. Right? I'm saying that this is a user replying to that post. Okay. I also keeping track of the create and the updated, just like before. I'm saying that this ID here is a primary key. I have two indices, although I don't need them. And I have two constraints. I'm saying that these two fields, the user ID and the post ID, they are going to be foreign keys that are going to be referencing. I'm going to be referencing, one is going to be referencing the users table and the other one's going to be referencing the posts table. And which fields in those tables? The ID fields, the primary key fields. And if you remove the user, I want all the replies from that user to go away. Or if you remove the post, then I want all the replies to go away. Right? It makes no sense to keep track of replies if you don't have the original post, or if you don't have the original user who created those replies. Okay, so blow them away. Okay, all right. So if I select this and I run it, right, it says it was okay, and we can refresh this, and we say we have the replies table there. Okay, perfect. So this implements this many to many. All right. Now let's take a look at implementing this loop here. Right, this loop basically is going to allow us to create a kind of like a recursive structure, right, where that allows you to create, hierarchical structures where you have a root that then you have many children, and then each children can have many children, and so on and so forth, right? So you can have like branches. So this structure allows you to create those kinds of relationship, the one-to-many here, looping of self-referencing yourself allows you to create those recursive definitions. For instance, in Java, you would implement this by having a class variable, right, being of the type of the same class that you are defining yourself in, right, which allows you to point to other instances of yourself, right, that, for instance, if you want to create a category, right, with products, a product category, you might have a root category, and then you might have multiple subcategories that all point to the parent root category. And then you can have all the subcategories that point to a particular subcategory above them, right? So only the root doesn't have any parent and it's null, and that's the root of the tree. Right? So this is what allows you to do this, right? So this is a field that is referencing other records in the same table. Okay. So notice that we did not implement this in this create table. We didn't implement it. Instead, we're going to implement it. We could have tried to do this. We could have tried to create a field called replies table, right? That references itself, and then a foreign key saying that field references the same table, but the primary key in that same table, right? But this would have failed. It would have failed because it's referencing a table that doesn't exist yet, right? Because we're creating it right now. So this would have failed and says, no, you can't reference something that doesn't exist, right? So what we're going to do is that after we have created a table, we're going to modify the table. What we're going to do is that we're going to use another command called alter. Alter table, what it does is that, like the name suggests, it modifies that table. It says which table we're changing? We're changing the replies table. We're going to add a brand new field called replies ID. I want to put it after the post ID. Notice I have a post ID there, right? So I want to show it. I want to add it right after the post ID and an index. I don't really need the index. And once the field has been added, I'm going to alter it again. I'm going to add a constraint. I'm going to say that field I just added called replies ID, I want to make it a foreign key that is going to reference itself, the table of replies, the primary key inside of that table. And if a reply to reply to reply, if the parent reply is removed, then all the child replies are also removed. I don't want to, if the parent reply goes away, why keep all the children replies? Yes? So let's do that. Let's copy this. Let's bring it over to our SQL and let's paste it underneath. I'll paste it there. And I can select it so that this runs, but before I run it, let me change it so that it's pointing to the correct schema. Let's see, Eric Zhu just raised their hand. And
yeah, the same question in chat. You cut out there for a second.
Sure. Let's cover again the alter. I think that's what might have. Can you repeat that quick? I think I heard it. Okay. Yeah. So here, let me repeat the alter. We said that that we were trying to implement this little loop over here, right? And the way you would have implemented it is by adding a field here that would self-reference the table, but we couldn't, right? We could have done this, or we could have tried to do this, right? Add replies field that is a foreign key that references itself, references the same, that's the table that we're trying to create. And this would have failed because the table doesn't exist yet, right? But it said, sorry, that table doesn't exist, right? So instead, what we did is that we created a table first, right? And then we are going to try to modify or alter the table. And we're going to say, okay, alter that table. We're going to add a new column called replies ID after the post ID. And so once after we add the column, we're going to alter again. We're going to say, hey, that field you just created, I want to make it into a foreign key that references the same table that's in replies, right? And references the primary key in that table. Okay, so let me copy that too. All right, so I'm going to just paste this down below, fixing the schema that I'm working on. Okay, oops. So let's first execute this. I'm going to highlight this code here. I can do either this lightning bolt, or on a Mac you can do command return, and on PC I think it would be control return, and that would execute it from the keyboard. So I'm going to do command return, and notice that it was successful. It was successful, and you should be able to see in the replies. Right, you should be able to see that new field, right? Actually, no, unless you refresh. There it is, replies ID. See that, right? But it's not a foreign key, right? If I go to replies and I try to alter it, I can see that my foreign keys are still only those two, right? The posts and the users, right? So we're going to close this. I'm going to run this. So command return, there it is, it altered it. Right now, if I try to review this, I can alter here. I can see that now in the foreign keys, I have 3 foreign keys. One referencing the post, one referencing the replies, and one referencing the users, right? Exactly what I needed. Okay, so now we do have implemented this entire class diagram, okay? Okay, so having done that, we're gonna save that. Save that, save, paste that, there we go, save that. And then you try it. We're going to ask you to try implementing this many-to-many. You create the ratings table with that maps users to posts, right? With the likes and the score and the comment, right? And so basically rating is going to have 2 fields, right? 2 foreign keys, one to user, one to post. There is no loop here, so there's no need for having a field that references itself, blah, 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 right? That was in the previous example. You don't have to do that for the ratings, okay? So try to do that. It should look like very similar to this one, right? So you have an example of what it might look like. So you try doing that and save it into a create ratings table.sql, and then you can submit all those tables. Submit them as files for your in Canvas. Okay, that makes sense. All right, let's move on. We've covered the assignments. Let's go back and review some of the concepts that we just covered. So let's see. So we are going to be using tables from now on, right? And basically, this is the relational model, right, which builds data structures using tables, right? And relations between records, records inside of rows, inside of the tables, right? That have fields. Some of those fields have data types. They can be integers, character strings, floating point, blah, 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 right? And so some of the example tables that we've been using so far are the student, department, courses, sections, enrollments, right? From previous slides that we've covered it, and they're implemented as tables that have rows and fields and have foreign keys that are related to each other, right? The major ID is a foreign key that references a primary key in the department, and the enrollment has two foreign keys. It's a mapping table, right? That maps students to the sections that they enrolled in. Okay. Now, what you might ask, well, why aren't we using one big table? Why do we even break it up into so many tables? And the reason is, as we'll see a little later, is that if you had only one table, you will find yourself repeating yourself over and over. For instance, here we're capturing the fact that Dan is the professor in a particular section, right? That folks are studying chemistry or calculus, right? And so this is redundancy that could cause inconsistency that we want to avoid. Instead, using this implementation, you capture the fact that Dan is teaching that particular course or that section, right? Only once. You capture that information only once, as opposed to capturing multiple times, right? Here, this could cause the fact that just like the two watches that logically should have the same value, for some reason, this is typed as Daniel instead of Dan, right? And that's inconsistency, right? We want to disallow or make sure we minimize those kinds of issues, right? So how do we create these tables? Student table, department table. We use the create table statement, right? So here's where we're creating the student, right? With the student ID, the primary key, but we'll look at that in a minute. Also, before we go any further, null, right? What we mean by null in SQL, we mean that that we don't know the value of a field. It doesn't mean that it's empty string, or doesn't mean that it's some special characters like 0 or -1 or whatever, right? It means that somebody was filling out a form and they didn't type the value in there, right? They didn't write anything in there, so we don't know what the value is, right? That's going to come back a little later. It'll be very important. So keys. So keys are fields in the table, right? Fields in the table that uniquely identify a record, right? And so we want to specify, what is the smallest set of fields that uniquely identify us, right? Obviously, uniqueness depends on the scope, right? For instance, my phone number without country code is unique within this country, right? But if you go further out and in the whole planet, then you need to add the country code, right? So if you start locally on my town, right, it might be my 7 digits is enough. But if you go between towns, then you need the area code, right? If you go beyond the country, then you need the country code, right? So the bigger the scope, right, the more keys you need to make it unique. Yes, and when Elon, gets us to Mars, then we'll need an area code. We'll need a planet code, right? So the bigger the context, the more keys you need to make something unique, right? So we want to know what is the smallest set of things or fields that we need to make something unique. Now, we can't use the order in which items are inserted into the table. Let's see, a question in the chat. Mars phone number is going to start out with 2 digits. Yeah, what about internet? I don't know. Have a phone call, you have like a 20-minute delay. So yeah. Yeah, we can't use the row order, the order in which we added them. I mean, you could say, well, I'm in the first row, second row, third row. I mean, that should be unique. But we don't want to know about the implementation and how this is being stored in the database, in the file, right? We want to stay at the logical level. And so we need a field that we can uniquely identify. So what is the smallest subset of fields? And so imagine we'd say on Earth, right? A phone number has it has the phone number, it has the area code, it has the country code. Can we add anything else to make it more unique? Probably not. Okay, what if you add the first name and last name that it belongs to? Would that make it any more unique? No, it wouldn't, right? It already has all the fields to make it unique within the context of this planet, right? So a super key is the fields that you might have chosen, right, to make a record unique, right? It's the combinations of all the fields in your record that might make your record unique. Now, you might have chosen certain fields that don't make your record any more unique. Like, for instance, if I have my phone number and I add email and first name and last name, those fields don't make the record any more unique. Okay, so we say that a key, right, that that makes a record unique is the set of fields that don't have any superfluous field, right? So, and by this we mean keys that don't make you any more unique. So for instance, if you have a phone number in your record, right, and you add first name, last name, and all those don't make you any more unique, right? So the first name and last name are superfluous fields, right? So the phone number is enough. The area code, the country code, right? All the combination of all those fields already make the record unique. So that's the key, right? The smallest set of fields that make the record unique. Okay. Okay. So how do you say that you choose? How is it that you choose fields, right? Or keys? How do you choose keys? So one way that we might be tempted to choose keys or values of keys is by looking at the values that we have, right? If somebody gives us a dump of some sample data, right, we might notice that maybe within a particular context that the last name is makes us unique. And somebody might say conclude that, hey, why don't we use the last name to be unique, right? But they might have concluded that only because they looked at the data, right? And might say, oh, look, it doesn't repeat. And so they might have concluded that it's unique. And but somebody who knows more about last names or first names and whatnot might actually conclude that no, actually a last name is not a good choice because it might very well, we just got lucky, right? That the data set that they gave us didn't have any last names repeating, right? But certainly it does not extend or it doesn't scale very well with more realistic data set, right? So you should not use the content to conclude whether a key is a good choice or not. Instead, it should be the logical understanding of what that key is and how it combines with other fields in your records. Okay, you could definitely combine fields, and not only to make them unique, but also it might enforce certain rules, certain business logics of your application. So for instance, we saw last week when we were designing the database that say there was a rule in the university saying that students cannot be enrolled more than once in the same section. I think that's a very reasonable rule. And how would you enforce that? Well, the way you could enforce it is in the enrollments table. You could, instead of using the I already did it. Instead of using the EID here, right, as the primary key, instead of doing that, you can remove that. Okay, you can scratch that. strike it through and say, instead, what I'm going to use is a combination of these two other fields, the section ID and the student ID, and the compound key is unique, right? So you cannot ever have the same student in the same section more than once. Okay, so keys can help you, enforce certain rules, right? Or constraints. We call constraints. What we call constraints are, any validation that we can ask the database to do for us. So for instance, if we say that a field is an integer, or date, or varchar, right, or string, we're telling the database to please work with us and enforce these constraints, right? That if I'm asking for an integer, don't let them type in any letters, right? And things like that, right? And so anything that validates data, we call it a constraint, right? To make sure that it doesn't go beyond its borders, right? So a couple of other examples, duplicate records. So the database actually doesn't enforce that records need to be unique, right? We're only enforcing it ourselves because we want to work with records to make sure that they all have different values. Actually, the database is perfectly fine letting you insert 2, 3, 4 records that have identical values in all their fields. Okay. Now the problem with that is that once you have that data in there, there's no way to distinguish one record from another record. Imagine this. These were 4 employees that have exactly the same information. There's no primary key, right? There's no unique key, okay? And the database doesn't force you to have any field to be unique. So you could totally do this. Insert 4 records that look identical. So say these are 4 employees, and you want to give one of them a raise. Well, there's no way that you can say, hey, update this user, right, whose username is, I want to give them a raise, a salary, right, and a salary raise. Well, there's no way for you to say that you're going to give a raise to one of them and it's not going to give it to all of them, right? Because the database can't tell them apart. Because if you use a username or first name or last name, if it's all the same, right, all the records are going to be treated as one. Even when you delete or do something, right, they're all going to be deleted all at once. So we have to, even though the database doesn't enforce uniqueness, we will do that by adding primary keys, right? We're going to declare one of the fields, we're going to declare them as primary keys. And primary keys are going to add a constraint saying that those particular fields or keys, right, are going to be unique. Okay, they have to have a value, they can't be null. And later on, we'll see, it'll allow us also to have records that have primary keys to participate in relationships with other records, right? Other records are going to be able to refer to you because you have a primary key. Okay. No, so how do we, and the way we do that is by using the primary key keyword, set of keywords, right? Primary key, and then the field that we want to be primary key. Okay, so now that we have a primary key, they work in tandem with foreign keys. So foreign keys are meant to have, to be fields that are going to reference other fields, right, in other tables. Could be in the same table, right, if we want to do a self-reference, if we want to do the loop-de-loop that we did earlier, right? But for the most part, it's you're referring to records that live in a different table, okay? Now, when you refer to records in another table, you need to refer to the primary key. Okay, so foreign keys refer to primary keys. Okay, excuse me. And we saw examples of this in the student major ID, the course had a department ID, section says course ID, and so on and so forth, right? And the way the syntax is that here we have a department table. And we're going to create a foreign key that references this department. So this department has a primary key. There it is. Perfect. And then we're going to refer to it by, creating a student table that's going to have a department. Maybe this should be department ID over here. And department ID is going to reference the department table, the department ID, the primary key listed here, right? And we are cascading, the deletes. Okay, what else? Let's see. This is just some naming convention. Right. So whenever you create this this relationship of foreign keys and primary key, right, you establish what it's called a referential integrity constraint. All right. Let's see. There's a question in the chat. You cut out again. Could you repeat that? Sure. Yeah. So yeah, we did create the department table, and with the primary key, there it is, right? And then we had the student table referencing the department by declaring a field called department ID that is going to reference. Here we're saying that foreign key, this field, is a foreign key that's going to reference another field in a different department, right? In a different table, right? And whenever you create a relationship between the foreign key and a primary key, right? We're establishing a relationship between this foreign key and this primary key. And what it does is that it asks the database to enforce the following constraint, right? To validate the following. Let's see, question in the chat. Thank you. Okay. And so this referential integrity, what it does is that by default, right? If you have a record that is referencing another record, right, you're establishing some kind of like a parent-child relationship, right, where the child is pointing to who its parent is, right? And the referential integrity constraint is going to say that you cannot, by default, you cannot delete the parent, right, because there's still a child, and you don't want to leave the child orphaned, right? You don't want to have the child referencing something that doesn't exist anymore, right? Very much like when you have files in a directory structure, right? If a directory contains files, right, the operating system doesn't let you delete the parent directory if you still have files under there, right? It stops you. So same thing here, right? The database is not going to allow you to delete parent records if you have children referencing that record, right? So here's an example where you have many students, right, records referencing a department, the math department, right? And so several things could happen. By default, if you try to remove the math department, the database is going to stop you because you're going to break referential integrity, right? And it's going to say, well, you can't remove the department because you still have students referencing you. If I would let you do that, I would leave the students orphaned, right? They would be pointing to something that doesn't exist. Okay. So that's one of the things that could happen. I can override that behavior though. I could say, well, let me remove it anyway, right? If I remove the department, then just ignore it, right? That's one of the options where I could say no action, just ignore it. Or I could say instead change these values, maybe make them null, right? So that they're not referring to the department anymore. They're just empty, just null. Or I could say that whatever happens here is going to propagate, right, to the other records, right? If I change the value, to something, 21, 22, that's going to propagate down to the children that are referencing the parents. Okay, so that's a cascade, an update cascade any updates down to the children, right? Or if I remove the department, I want to cascade that delete down to my children as well. So if I'm removed, all the other ones are removed, and that's up to you what you want to do, right? And those are what we call the cascade actions, right? That we want to cascade the delete. We want to cascade the updates down to the children. Okay. Yeah, change or updates. And integrity constraints, right? That we want to make sure that you're not changing something that can't be changed. That you can't leave something that is null, that it's not null, right? Or you can't modify it, because somebody's referencing you. Okay. And just specification of tables. All right. All right. Excellent. Let's move on. Any questions? Right. So here in the relational model slide, here a couple of examples of using MySQL Workbench to create certain types of relationships. So here's the one-to-many relationship between, say, a website having many pages, and notice that it has a composition, right? It's a blacked out, filled in diamond, meaning that presumably if you remove a website, it would also remove the pages associated with it, right? And here's just a couple of screenshots of creating these tables, right? So I'm just capturing what we did earlier in Workbench, right? And these are the resulting tables, the source code that the graphical user interface creates for you, right? And here's how you would maybe insert into these tables. Also, I'm capturing the fact that this is a composition, right? So meaning that any updates or deletes to the website are going to cascade down to the page, right? And so the way we do that is that we have a field here, website ID, that later we're going to select what it references, which field it references in the other table, and then the field, the local field on the current table, and the field that it's referencing on the remote table. And then checking to see that you want to cascade all those updates or those deletes. You want to make sure that if those records are removed, these records are removed as well. Okay, so I just copied some examples here. Normalization. I have a whole set of slides for that. Let's jump over to normalization and cover that before coming back to here. So let's talk about normalization. So by normalization, what we mean, right, is that as I mentioned earlier, right, we're trying to avoid redundancy, right? Meaning, like for the example where I showed you earlier, that we might have a table that has a lot of data that is the same. I believe I had it here, right? So let me copy that and put it here. Okay, so let me paste it right here. There we go. Normalized data. Do not link. Yeah. So here's the impetus, right? That if you have big tables, right, but you're going to tend what's going to tend happening is that you're going to have a lot of fields that have the same value over and over. So a lot of records that are going to have values that are repeated over and over, right? And redundancy breeds inconsistency. So there is an impetus for breaking these tables apart, so that the values are captured only once, right? So for instance, let me copy that and let's paste it here as well. I think this is a good example, right? Do not link. I copied the wrong table, the wrong slide. I meant to copy this one. Copy. And do not link. Yeah, so why not a big table? Because we want to normalize it. This is a normalized database, right? As opposed to this is not a normalized database, right? Notice that this Dan over here is being captured multiple times, whereas over here, Dan is going to be captured only once. See that? So basically, normalization is going to try and break up pages, tables in such a way to avoid redundancy. Okay. So how are we going to do that, right? So there are many different things that could go wrong when we are designing our tables, right? And they all have very specific names, right? They're very typical things that happen, right, that we want to avoid. So first, let's talk about the simplest one. It's called first normal form, right? And this happens when we have a field that has repeating values in the same field. Why would this happen? Let me show you with an example. So imagine you had the following data, right? You had these folks, Alice, Billy, Daniel, and they all have their own phone numbers. Okay, and you might feel that this is enough, right? The database was designed this way; it was very simple. But as you start using it, you realize that folks might have multiple phone numbers, right? And you might be tempted to do this, right? Where a very easy design change would be that now you make your field plural, and you're going to allow folks to paste multiple phone numbers in the same field. Okay. Now this has performance issues. Also, when you do queries and you retrieve data from the database, if you retrieve and you update this data, right? Because before it was clear that this contained a single phone number, right? But now it might be an array of numbers, right? and databases don't support arrays, right? The best thing you could do is to maybe concatenate these and have a special character to know that these are, there are multiple values. But this is for optimization is very bad for indexing and for retrieval of data. Say you're searching a record for a specific phone number. Well, now it's complicated because now you don't have just a single phone number, you have multiple phone numbers. That means that you need to do some string manipulation. You have to split these telephones, right? And then iterate over the elements in some array. So it complicates the query. So definitely it's a very bad practice, right? If you see something like this at work, you could say, hey, your database is breaking first normal form with a lot of confidence, right? Another common way of trying to solve this problem might be that you say, well, what if I have multiple columns, one for each one of the phone numbers, right? And again, this also is a bad option because you don't know how many phone numbers you're going to have, right? There might be somebody who has 3 phone numbers, right? Or no phone numbers. Why even have a column here? Okay, so this doesn't expand well, right? Doesn't grow very well, right? So definitely not an option. The other option could be that instead we leave it like it was, but we enter 2 separate records, right? One where I have one of the phone numbers and another one where I have the other phone number, right? But then this is also problematic because we are making redundant the other 2 fields, right? The first name and the last name, right? We're going to be repeating that over and over, right? So that's also a bad idea, right? So again, if you see that implemented at work, either doing this or that, right? You would say that you are breaking first normal form, right? And it's not normalized. Okay, so what do we do? What's the option that we are going to choose? So what we're going to do is that we're going to normalize it as follows. We're going to break up this table into 2 tables. One, which is going to store all your customers. And in a separate table, we're going to store the phone numbers, right? So it's very distinct, the type of information that you're storing, right? One is customer information and the other one is phone number. And here you can put all the phone numbers that you want, and then you can use foreign keys to use for referencing the customers, right? So that we know what phones belong to what customer. Okay, right. So that was first normal form, right? And so definitely all our fixes of normalizing data are always going to be a splitting of a larger table into smaller tables, right? So let's look at this other one. Here's another one. This is something else that could go wrong, right? And let's take a look at this data that we have here, right? So here we have a table that has a composite key, meaning that it's using these 2 fields as a combination to be its primary key. It doesn't have a primary key all by itself, but it has multiple keys, right? Multiple fields. And meaning that we are enforcing that the combination of these 2 values is unique. So one of them could repeat, right? Which is fine, right? This repeats over here, this repeats over there, right? But the combination does not repeat, okay? So it's a proper primary key. Okay, so there's nothing wrong with that. And 2NF, 2NF exclusively deals with problems that arise when you have, a composite key like this, right? So what's wrong with this table? Well, let's look at the other fields, right? If we look at the other fields, it looks like these seats. Notice that let's look at 5200. 5200 in this semester had 200 seats, and 5200 in this other semester had 150 seats, right? So it looks like this field here is dependent on the combination of what course, right? One course, one semester, one value for seats, and the same course in a different semester might have a different value of seats, which is perfect. So this value here depends on the whole key. It depends on both of the fields that make up the whole key. Make sense? Let's look at the course name over here. Right, so this course name looks like the values of programming databases and databases looks like they are only dependent on the course ID. See that? If you know this course ID, let's see, did I, is there a reason why CID couldn't have been the only field in the primary key? Sure. I'm making up an example where I need a composite key. Can you please repeat it? Can you repeat it? It cut out again. Yeah. So let me repeat this again. Right. So yeah. So I need an example where I need a combination of two fields to make up an entire composite key. Okay. And because 2NF, 2NF is specific to composite keys, right? Things that might go wrong when you use composite keys, right? And one of the things that could go wrong is that some of the fields, right, will depend on both keys. Like for instance, here 200 is, you might have 200 seats when 5200 was in this particular semester, but it might be 150 if the same course is in a different semester, right? So the value for the seats depends on the combination of the course and the semester. Whereas course name over here seems to depend only on the course, right? The name of the course, right, is dependent on the course ID, right? Databases is 5200, right? It is independent. Let's see something on the chat. As we have primary key options in the workbench, is there an option to composite keys as well? Yes, yeah, you can when you define a table, right? And here when you're defining a table, you can select multiple primary keys, right? And what it'll do is it'll create a composite key for a combination of all of them. Okay, so you can select any number of primary keys, and those are composite keys now. Okay, I didn't mean to do that. Let me. I don't want to save that. So yeah, that's how you would create it. Chat. All right, thanks. Yeah. So so this field, the value of this database only depends on this on half of the primary key. It doesn't depend on the whole primary key. Make sense, right? And that's bad, right? That could create problems. And usually the way we fix it is by, again, splitting up the bigger table into two smaller tables, right? So what we're going to do is that we're going to split and say, well, we're going to capture the information about the seats in one table and the information about the courses in a different table, right? So here it is. Now it's split. We have the table that only has the seats, and then we have the course information about the course name, and this would be a foreign key that references the primary key in a different table, all right? And let's look at another example. Here we have Alice, right, having these skills. Alice has QA skills, Alice has CSS and HTML skills, right? And so Alice, the combination of Alice and skills is unique, right? It would make no sense for Alice to have the same skill twice, okay? So we make that into a composite key, and we are enforcing the fact that the combination of Alice and the skill is unique, okay? Now here we're capturing the fact that Alice is working in Cambridge, right? And Bob is working in Newton, and Charlie and Dan are also working in Newton, okay? So it looks like this data over here, this field is dependent on the person, because a person usually cannot be more than in two different places at once, right? Alice can only be either in Cambridge or Newton, but not in both places, right? So this is always Cambridge, right? If this is always Alice, right? And same thing for Charlie, right? And being in Newton over here, right? So we see the same problem, right? Where the field, one of the fields is dependent on half or partial composite key, right? And the fix is we split it into two tables where we're going to capture the location in one table and the skills we captured maybe in a different table. Make sense? Right? And then there's yet another example, which we're going to go over next time around. And we're going to illustrate why even fixing this might not fix everything. There's other examples of redundancy that we want to avoid, and that's going to give a segue into the 3NF, right? And we'll talk about 3NF when we come back next time. Okay. All right. Any questions? That's all I have for you today. Any questions? Sorry for the breaking out, but hopefully I repeated and you got it all. And it should be available the recording either in YouTube or in Zoom. Okay. Remember on Friday we'll have the quiz. NF stands for normal form. NF, normal form. Yep. Awesome. Thank you, everyone.
I have a question on 2NF. When you
Yeah.
split into two tables, one of them was employee and skill. So it's literally a table where its features are combined into one primary key. Just both attributes are part of the primary key.
Yes.
Oh, okay.
Yeah, 2NF, the analysis of 2NF only applies to composite keys, tables that have a composite key. Okay. All right.
Okay.
All right, thank you.
I had a quick question on submissions on Canvas.
Yeah.
So for the first assignment, I submitted all the files zipped up together, but I lost points for that because when it says you should deliver these 4 files together, I didn't know you could submit them separately.
No, you shouldn't. Yeah, you shouldn't do that. That shouldn't have happened. So send a private post to all instructors, which I'll be CC'd, and I'll reply saying that not to do that, to give you points back.
Okay, so would you? I guess the TAs would still prefer 4 individual deliverables instead of the zip file.
It's more convenient for us, but definitely you shouldn't. You shouldn't be penalized for doing that.
Okay. All right. Thank you.
Okay. So are we allowed to resubmit the homework? You can resubmit. I think it's indefinite. You can resubmit anytime. Obviously, you should submit before the due date. And if it has been already graded, the TAs might have already graded because you might have submitted, last Friday or something, and they might have gone out and submitted it. If it gets resubmitted, please let the TAs know that you resubmitted it so that they can take a look at it again. Or if you could abstain from submitting, if you're not going to be done or you're not done yet, right? Only submit when you are sure that that's what you want graded. Otherwise, you're going to create a lot of chatter back and forth, and folks having to be regraded.
Yeah, I just realized I messed up something in my UML.
Yeah, that's fine. Yeah, we definitely want to allow you to resubmit, up until the submission due date.
Yeah.
Of course, do that, but make it because you found something below. But no, don't be overzealous and submit really early. If you're not quite sure if you're done.
Oh yeah, sounds good. Thank you.
Thank you.
Have a good one.